At 6:39 a.m. on January 28, 2022, bus driver Daryl Luciani felt the road disappear beneath him. The bridge was bouncing, shaking. In his mind, he already knew. The Fern Hollow Bridge was collapsing. 10 people fell 100 feet into a snowy ravine. Miraculously, no one died. But the official NTSB investigation reveals this was no accident. This was 15 years of warnings, ignored. The Fern Hollow Bridge carried Forbes Avenue over Frick Park in Pittsburgh's East End. Opened in 1973, it was 447 feet long, standing 100 feet above a walking trail. 14,000 vehicles crossed it every day. School buses, commuters, delivery trucks. The bridge used a K-frame design with weathering steel, meant to develop a protective rust layer. But something had gone very, very wrong. Here is the official NTSB investigation page. Case number HW A803. The National Transportation Safety Board spent 2 years investigating this collapse. Their verified findings are damning. The bridge had been rated poor since 2011. Inspectors documented the same maintenance recommendations year after year, and the city of Pittsburgh failed to act on them for more than 15 years. In December 2018, a local software engineer named Greg Kochanski walked beneath the bridge and saw something alarming. He tweeted a photo to Pittsburgh's 311 account. "I hope someone is keeping an eye on the underside of the Forbes Avenue Bridge. One of the big X beams is rusted through entirely." The city opened a ticket. A few weeks later, they closed it. They removed the corroded brace but never fixed the underlying problem. The NTSB found that inspectors documented the same problems over and over. Clogged drains, corroded steel, holes in the legs. In 2007, they first noted holes in the metal. In 2009, the city installed temporary steel cables. Temporary. The long-term fix was never completed. By 2021, the final inspection found 50% of the bolts in critical sections had deteriorated. 4 months later, the bridge collapsed. Weathering steel is supposed to form a protective rust layer called patina. But the NTSB found that clogged drains caused water to run down the bridge legs and pool at the bottom. Leaves, dirt, and debris accumulated. This prevented the patina from forming. Instead of protecting the steel, the moisture accelerated corrosion. By the time of collapse, some areas had lost 75% of their original thickness. Here is the official NTSB report. Report number HIR 2402. The probable cause, failure of the transverse tie plate on the southwest leg due to extensive corrosion and section loss. This is the exact component that gave way. The investigation found that multiple inspectors, contracted by PennDOT on behalf of the city, failed to clean corrosion before measuring, failed to accurately quantify remaining material, and failed to recommend a structural review. But there's more. The NTSB discovered that the asphalt surface on the bridge was nearly double the thickness shown in inspection reports. No one had accounted for this extra weight. The load calculations were wrong. At the time of collapse, the bridge did not have the capacity to handle its recommended load rating. They had been overloading a bridge they knew was in poor condition for years. January 28, 2022, 6:39 a.m. Light snow had been falling since 3 a.m. Schools were delayed 2 hours. 5 cars and an articulated bus were on the bridge. The southwest leg failed first. The transverse tie plate fractured. The bottom flange separated from the web and curled back on itself. Within seconds, 447 feet of steel and concrete dropped 100 feet into Frick Park. A gas line severed. Residents smelled gas for blocks. Daryl Luciani wasn't even supposed to work that day. He picked up an extra shift for overtime. He'd driven across this bridge hundreds of times. As I was driving, I knew in my mind the bridge was collapsing. I could feel it. The bus was bouncing and shaking. He put on the air brakes, unsure if the bus would slide backward. First responders used ropes and a ladder to rescue him and his 2 passengers. The region contains other structures with similar designs. Following this event, 5 specific locations were flagged for immediate review. The engineering board recommended new protocols for inspecting non-redundant steel frame designs. The failure occurred on the same day a major infrastructure announcement was scheduled in the city. The site became a focal point for discussions on asset management and maintenance funding. A replacement project was authorized immediately. The final engineering statement concluded that the event was preventable. The structural condition warranted an earlier closure. The failure was attributed to a lapse in the maintenance cycle and load rating assessment. The site was cleared, and a new design was implemented. The replacement structure was completed and opened to traffic in December 2022, less than a year after the original frame failed. This case study highlights the importance of drainage maintenance in weathering steel applications. Structural integrity depends on keeping critical connections dry. Next, we analyze the engineering factors behind the Francis Scott Key Bridge event. Follow for more technical reports.